Lesson 6.3, solving compound inequalities. Okay, so this is going to take a minute. Okay, let's look over here for a study tip. It says, for inequalities using the word and, a number has to be true for both inequalities in order to be a solution for a compound inequality. Okay, so here we have it, compound inequality. Two or more inequalities, so two or more inequalities that are connected by the word and or the word or. Intersection, the overlapping section that represents the compound inequality. Okay, so if I look at this, if I have this part right here, x is greater than -4. I come over here, I graph that on the top line. Then I have x is less than or equal to 3. Now the parts that they have in common are from here to here. That's the part that's in common. That part is the solution. This part right here is the solution. Now, how did this get a solid dot? Because this would have been a solid dot here and a solid dot here. They have both of those numbers. Why is this one over here an open dot? Because this one has an open dot. The fact that it is not closed means that automatically it's going to be an open dot. So here we go. Some of you are like, what? Guys, when we solve this, we're going to, if I was doing just this right here, wouldn't I just add 2 to both sides? Well, this time around, you're not just adding to 2 sides, you're adding to 3. So you get -6 less than or equal to h, which is less than 3. And then you come down here. I go to -6, and this has a closed dot, this has an open dot. So at -6, I put a closed dot. At 3, I put an open dot. And it's all the stuff that's in between. Okay. So let's look at this one. Okay, same thing. I need to get rid of this part right here. The opposite of adding 2 is subtracting 2. I subtract 2 here, here, and here. So -9 is less than or equal to 3x, which is less than or equal to 3. I need to get rid of this 3 that's here, and it's multiplied by x. So the opposite of multiplication, or the inverse operation, is dividing. So I'm going to divide everything by 3. So -3 is less than or equal to x, which is less than or equal to 1. So I come down here. They're both closed dots. So I go to -3, which is going to be right here. And I go to 1, which is right here. And it's all the stuff in between. And I forgot to write set builder notation above. So x such that -3 is less than or equal to x, which is less than or equal to 1. And then if I was doing interval notation, -3 is the lowest number, 1 is the highest number, and they're both included. Let me go back here and let's do set notation for this one. It's going to be -6. Oops, what am I doing? H such that -6 is less than or equal to h, which is less than 3. That was a horrible, there we go. If I was doing interval notation, I write down the -6, write down the 3. The 3 is not included, so it gets a parenthesis. Okay. Serial manufacturer distributes cases of cereal to grocery stores. Each case contains 12 boxes of cereal. In order to pass manufacturer's quality assurance test, the case must weigh between these two. Okay? Which includes 34 ounces of weight of the case's cardboard box. Write an inequality. Okay. So we know it has to be between 336.4 and 331.6. Has to be between those. Okay? So there are 12 boxes inside. So 12 times the weight, plus you have 34 ounces for the box. The box weighs a certain amount. So I have to subtract 34 on both sides, or I should say on all three sides. And I should have a calculator out for this. Calculator. So 331.6 minus 34 equals 297.6 is less than or equal to 12x, which is less than or equal to 302.4. So I take these and I divide everything by 12. So I get 24.8 is less than or equal to x, which is less than or equal to divided by 12. 25.2. So 24.8 25.2 Okay. Keyshawn has been saving to buy his first car. He wants the total cost of the car and fees, so car plus fees, to be between these numbers. So 5,000 and 7,000. The fees for buying the used car, such as the title, registration, and will be $700. So the fees are $700. So C plus, we want to be between that. So I subtract 700 from both sides. Or sorry, all three. So that would get 4300. That would get 6300. So it should be between that. Okay. So 23 about here and 63 about here. Okay. An application problem that implies inclusivity, which means the numbers mentioned will be included, are these symbols. Okay? So, if it's these, the numbers aren't. So this has the brackets, this has the parentheses. So a union, the graph of the compound inequalities contains the word or. The solution is the solution for either inequality. So if I look at this and it's written like this, the solution are both of these parts. So we had the first part up here, greater than or equal to 1. Then we had less than or equal to -3. The solution for that are both of the parts. So on this, you're going to have to solve both of them. And the word or goes all the way down. So I subtract 8. I get 4n less than or equal to 8. Divide by 4. And I get n is less than or equal to 2. Or I subtract 7 from both sides. Get negative 3n is less than negative 18. I divide by negative 3. I divided by a negative number, so my inequality changes directions. So it's going to be either or these. So at 2, I have an open dot. No, I have a closed dot, sorry. And it's less than, so it's all these. Or I go to 6, and that's an open dot, and it's all the stuff that's above it. Those are my answers. So let's do it again. Again, or. So I subtract 1, I get 5x is less than 10. I divide by 5, and I get x is less than 2. Over here, I subtract 10 from both sides. I get negative 3x is less than or equal to negative 21. Divide by negative 3, so that's going to switch my inequality and have a positive 7. So 2, open dot, and it's all the stuff less than. And then I go to 7, and it's a closed dot, and it's all the stuff above it. Oops. I forgot to answer these questions down here. What is the solution set? So the solution set is n is less than or equal to 2, or sometimes you see a u for that, meaning union. N is greater than 6. So interval notation is going to be less than 2. U going to 6 and going to be all the numbers greater than it. Set builder, n such that, oops, let me erase that because that was ridiculous. N such that n, nope, is less than or equal to 2, union n is greater than 6, or the word or. This one over here, you're going to have x is less than 2, or have a union, x is greater than or equal to 7. Interval notation, negative infinity to 2, union, oops, bracket, not parenthesis, 7 to positive infinity. Set builder notation, it would be x such that x is less than 2, union, x is greater than or equal to 7. Okay. Over here, doing it again, subtracting 12 from both sides. Oops, bring the or down. 4k is less than negative 10, divide by 4. Get k is less than negative 5 over 2, which is less than negative 2.5. Either one of those will work. Oops, I should have put it next to the or. Subtract 4 from both sides, get negative 2k is greater than 0. Divide by negative 2. I divided by a negative, so k is less than 0. Okay, this is an or statement, right, guys? So I come here to negative 1, negative 2, negative 3. So negative 2.5 is going to be here. Okay, 0 is going to be here. See how it goes all this direction? So the solution to this is actually k is less than 0. Interval notation, negative, not negative 8, but negative infinity. And then my set builder would be k such that k is less than 0. Okay, this one, again, I have or. Subtract 7 from both sides, get 4m is greater than or equal to 12. Divide by 4, and get m is greater than or equal to 3. Oops. How about I write that down just a little bit further. Okay, subtract 5. Get negative m is less than or equal to negative 5. Divide by negative 1. And get m is greater than or equal to 5. Oh. Oops, I didn't mean to put the 0. Okay, 4, 5, 6, 7. So here and bigger. Here and bigger. So that means the solution set is actually m is greater than or equal to 3. Interval notation would be 3 to positive infinity. And set builder is m such that m is greater than or equal to 3. Okay, so if I'm going to look at this one, oh, I didn't give myself a lot of space. We'll write, these are 4 different ones, guys. So if I look up here, my x's are going to be in between. This side over here has an open dot, so that means it's going to be this. Over here it has a closed dot, so it's going to be this. And then I write the number, so negative 2, 4. Come down here. This is going to be an or statement. So I look at this side first. X is less than or equal to 8. Look on the right-hand side, x is greater than 12. This is an and statement. It's between these two. So 7's on this side, 9's on this side. This right here is an open dot. This right here is a closed dot. Okay, this is an or statement. So if I look on this side first, I have x is less than or equal to negative 1. On the right-hand side, x is greater than or equal to positive 1.